In this video, I want to take a look at exam revision for angles. Now, in the previous video, we established the properties of angles, such as angles on a straight line, angles around a point, angles in a triangle, and so on. Okay. So if you do feel like you need a bit more preparation before tackling the questions in this video, then do check out the previous video. So let's jump into the questions in this video. So what I've got here to begin with is ABC, which is a straight line, and we're asked to find the size of the angle marked Y. So this angle here. Okay. So what we need to understand here is what happens with angles on a straight line. So remember, angles on a straight line must add to 180 degrees. So this angle here, Y, plus this angle here of 60 degrees must add to 180 degrees. So what we're saying then is Y plus 60 must equal 180. Okay. So what I want to do here now is just solve this equation for Y. So in that case, I'm going to take 60 off both sides here to balance this equation. So subtract 60 off both sides. Do the same here, and in that case we get that Y is equal to 180 minus 60, which in that case will give me 120 there. Okay, obviously you can do the subtraction here. It's column subtraction if you find that easier, but either way there, you should get that Y is equal to 120 degrees there. And that gives us the solution to question 1. Moving on to the next question now, what we can see here is we've got this diagram straight away, and what we're asked to do is find the size of the angle marked X. So that's this angle here. Okay. Now, if we just look at this diagram here, this angle straight away looks greater than 180 degrees. Okay. So in that case, we would expect a solution greater than 180 degrees. If we get something less than 180, then alarm bells should be ringing. So what do we need here? Well, what we're looking at is angles around a point. If this is my point here, then I'm looking at 3 separate angles. I've got this angle here of X, I've got this angle here of 51 degrees, and I've got this right angle here. Okay, this little square. So remember, this right angle represents 90 degrees. Okay. So what do we know about angles around a point? Well, we know that angles around a point should add to 360 degrees. So in that case, if I add these 3 angles together, they should add to 360. So I've got X plus 51 plus 90. And that should add to 360. Okay. Well, 51 plus 90, that would give me 141. So what I've got here so far, if I simplified the left-hand side, is X plus 141 is equal to 360. Okay. So what I'm going to do here now is solve this equation here for X. So we just want to know the value of X. So what I can do then is subtract 141 off both sides, so minus 141. Do the same on the other side as well. So what I'm going to get then is X equals 360 minus 141. Okay, and we'll do this using column subtraction here just so we can see what we've got going on. Now I like to think about this using place value when I do column subtraction. So I've got 0 units minus 1 unit. So in total there, that would give me minus 1 unit. I've got 6 tenths, so 60, minus 4 tenths, so 40. So 60 minus 40, that would give me 20. And then finally, we've got 300, so 300 minus 100 there. So 300 minus 100, which will give me 200. So what I need to do now is just add these 3 sums here together. So 200 plus 20 is 220. Subtract 1 from that, and I get 219 there. Okay. So what that's shown us then is that X is equal to 219 degrees. Now, if we just give our answer a quick sensibility check here, does it seem sensible? Well, it's greater than 180 degrees. Like we can see here, if this line was to carry on, the angle there would be 180. So if it's greater here, but this extra part, then it should be definitely greater than 180. Okay. So we get X equal to 290 degrees. Seems sensible. And that gives us our solution there to question 2. Moving on to question 3 now, we've got this triangle ABC here, which is presented on the screen. And we're told this is an isosceles triangle. Now these lines here indicate that these 2 sides are equal. Okay, so the length AB and the length BC are equal in size. So for an isosceles triangle, the base angles are the same. So that would be this angle here and this angle here. So if this angle here is 38 degrees, then this one here must also be 38 degrees. Okay. Now I want this angle here Z. That's what we're looking to find. Now, what do we know about angles in a triangle? Well, angles in a triangle add to 180 degrees. So this angle here plus this angle here plus this angle here must add to 180 degrees. So 38 plus 38 plus z, this angle here, should be equal to 180. Okay, so what I need to do here is just like we've done for the previous two questions, is just solve this equation now for z. So 38 plus 38, well, the way I like to think about this, just to make life easier, is think about making both of these 40. So 40 plus 40, that would be 80. And then subtract 4 off, because I've added a 2 to each of these to give me 40. So what I'm going to get then is 80 minus 4, so that's 76 plus z. Of course, you could do this using column addition as well if you want. But in life, we always want to make maths that a little bit easier if we can, and just spot these little tricks that help. So I've got 76 plus z is equal to 180. Now I just want z here, so again, all I need to do now is subtract this positive 76 off both sides, so minus 76 and minus 76 there. So on the left-hand side here, what we get is just z, and that's going to be equal to 180 minus 76 there, okay? So again, if we do this using column subtraction here, what I've got now is 0 units minus 6 units. So in total there, we've got minus 6 units. I've then got 8 tens minus 7 tens, so that's 80 minus 70. That would give me 10. So we get 10 there. And then finally we've got 100 here minus 0, 100, so I just get left with 100 there. So in total here, we just need to evaluate this final bit here between these two lines. So 100 plus 10, that would give me 110, minus the 6, that gives me 104 there. Okay, so z in this case, the size of the angle minus z, is 104 degrees there. And that gives the solution to question 3. Moving on to question 4 now, what we've got here is x, y, z, which is a straight line. Okay, so as soon as I see that point about a straight line, I'm thinking about angles on a straight line. So what I've also got here is this triangle, okay, which we're going to need to use in a moment. So thinking about the angles on a straight line first, what do we know they add up to? Well, angles on a straight line add to 180 degrees. So if we know this angle here is 139 degrees, that means we can also work out this angle here. Okay, if I call that little x, for example, here, then little x here is going to be equal to this angle here plus this angle here, x. So x plus 139 must be equal to 180. Okay, that's what we know by angles on a straight line. So again, all I want to do here now is just solve for x. So in that case, we're going to subtract 139 off both sides. So minus 139, and then do the same on the other side. So we get minus 139 as well. So on the left-hand side, we just get x here, and then I'm going to do 180 minus 139. So 0 units minus 9 units, that would give me minus 9. I've then got 8 tens minus 3 tens, so 80 minus 30, so that would give me 50. And then 100 minus 100, so I get 0 there. So 50 plus minus 9, or 50 minus 9, same thing, I'm going to get 41 there. Okay, so this angle here is 41 degrees, so we just get rid of that there, and just replace that with 41 degrees. Okay. So what I know now is two of the angles in a triangle. We know the numerical value of those angles. This one here, we're just saying that's A, but because I know the size of these two angles here, we can work out this final one. Because we know that angles in a triangle must add to 180 degrees, so therefore, just change the pen color here just to finish this solution. We've got 94 plus 41 plus x, A here, this angle A, must be equal to 180 degrees. Okay. And all I want to do now is just solve for A here. So 94 plus 41, what would that give me here? I'll just use column addition. So 94 plus 41. 4 units plus 1 unit, that would give me 5 units. 90 plus 40, so that's going to give me 130. So add those together, I get 135 there. Okay. So I get 135 from 94 plus 41, so I've got 135 plus A. And that's equal to 180. So what I want to do now is just solve that in the same way we just did here for this angle of x. So subtract 135 off both sides. Do the same here. So what I'm going to get then, if we do that over here, is we get that A is equal to 180 minus 135. So 0 units minus 5 units, that would give me minus 5 units. 8 tens minus 3 tens, I get 50 there. And then 100 minus 100, I get 0 there. Okay. We get 50 plus minus 5, or 50 minus 5. And what I get there for A is 45 degrees there. Okay. So this angle here is 45 degrees there. Okay, that gives us the solution to question 4. Moving on to the very last question here, what I can see straight away is we have this diagram. Okay, now this is a quadrilateral. We have 4 sides and we also have 4 angles. Okay, we've got 4 points A, B, C, and D. So for part A, we're asked to find the size of the angle ABC. So that's this angle here. Okay. Now we don't have a letter for that, but I'm just going to call it Y. Okay, it doesn't matter what we call it. You can call it any letter, but let's just pick Y for this example. So what do we know about angles in a quadrilateral? Well, we know that they must add to 360 degrees. So I'm going to add all of these together. So 102 plus 60 plus 82 plus Y. Like we said, all of these must add to 360 degrees. Okay, so what I need to do now is simplify the left-hand side here. So 102 plus 60, that would give me 162, plus 82, plus Y. And this again, all equal to 360. 162 plus 82 here, we do that up here. If I just use column addition here to do this, 2 units plus 2 units, that would give me 4 units. 60 plus 80, that would give me 140. And then finally 100 plus no hundreds here, I just get 100. So if I add these 3 things together now, 100 plus 140, that would give me 240 plus the 4, I get 2 over there. Okay. So what I've got now is 244 plus Y is equal to 360. Okay. So these 3 angles here add to 244 degrees. This one here is Y. So now I just want to solve for Y here from this equation. So I'm going to subtract 244 off both sides. Okay. So in that case, then I get Y is equal to 360 minus 244. So 0 minus 4, that would give me minus 4 units. I've then got 60 minus 40, so that would give me 20. I get 20 there. And then 300 minus 200, that would give me 100. Okay. So simplify these 3 numbers here. 100 plus 20 is 120. Minus 4, that gives me 116 there. Okay. So the sides of the angle ABC here, which I've called Y. So we'll get rid of the Y here and we can replace that with 116 degrees there. Okay. And that gives us the solution to part A. So for part A, you should get 116 degrees. And for part B, it says give a reason for your answer. So all we need to say here is because we're looking at angles in a quadrilateral. So angles in a quadrilateral add to 360 degrees. So we just make a note of that here. We don't run out of room, hopefully. Add to 360 degrees. So therefore, if we did 360 minus 244, that would give us the 116 that we need. Okay. And now, however, that's all we really need to say there for part B. Just obviously, we're making a key fact here of the fact that angles in a quadrilateral must add to 360 degrees. Okay, so let's make a note of that here. And now, however, that's our solution to part B. And that gives us our solution to question 5 overall, and that actually brings us to the end of this video on exam revision for angles. In the next video, we're going to take a look at area and perimeter.